Hello and welcome to the video. In this video, we solve exercise number 3-7 from Arena book. This exercise is built upon exercise 3-6. So we first open the exercise solution 3-6 and then we have to implement some changes. The changes is the parts that fail the inspection after being washed are sent back and re-washed instead of leaving the system. In the previous case, remember the parts leave the system, but in this case parts are not leaving the system. They are actually re-sent or sent back to the wash station for re-washing and then again re-inspection. And in this exercise, the probabilities of failing the inspection would remain same as in the previous days, as well as the other elements of the model would remain same. Only we have to implement this small thing in this exercise. As well as we have to run this model for 480 minutes and we need to compare the result this exercise to the previous exercise solution, that is 3-6, and we also have to comment on the inspection and washing station with these changing. Okay, so now let's move to the arena screen. Here's our model. So first of all, parts arrive to the system and they are randomly distributed with its value of 5 minutes. There is nothing changed in this module. There is nothing changed in this process module. Everything goes same. There is nothing changed in this module. Every values would remain same, and also in this module every value would remain same, as well as the decision boards have the percentage for true percentage value would also remain same, that is 75%. The only thing you need to change in this model is you remove the dirt part dispose module and simply move this action to this station like this. If you can like click this button and then add it here. So in this case now the parts that not are properly cleaned actually sent back to the washing center again, and after re-washing again re-inspection and then cleaning, the decision about this process either the parts are clean or not. If they are clean, then dispose or leave the system, else move back to the washing center. Okay, so these two charts showing the queue length and the number busy value and would remain the same um, data series as we discussed in the previous exercise. Okay, so run setup and we are running the simulation for 480 minutes and number of replication is remain same, that's equal to 1. Okay, so now let's run the simulation. So here you can see the queue length chart and number busy chart, and let's speed up the thing. So you can see that queue is actually start building up at the inspection because the parts are not leaving the system whose are not properly cleaned. So they are again moving back to the system. So this would increase the arrival rate of the inspection center. So how we can compute that? So first let's click the result view to view the results. Okay, so let's review the statistics. So under the queue menu, you can clearly see the inspection center dot queue value, average value is 25.27 and its maximum value is 56.08. And the queue length, the resource usage of inspector is 97.37%, and the time in queue entry that actually spent in the system So the number rating at inspection center is 6.5 and maximum value is 18. So you can clearly see the increase in these stat values with previous exercise stat values. So we can see, let's first close the report and rerun the simulation again. Let's fast forward it. Okay, so now you can clearly see there is a congestion at the inspection center is marked increase with this feedback loop model since the part that used to go away now come back to the inspection center. So in fact, the inspection center is exploding. And to see this, consider that the effective arrival rate to its value is 0.267 and this value is calculated from infinite geometry series and the equation is also shown on your screen. And remember 25% of the parts are actually going back to this feedback loop. Okay, and the service rate of inspection center is 1 divided by 4.5 that's equal to 0.22 and this value is less than the customer or entity's arrival rate. That's why the effective arrival rate is greater than the service rate. So in the long run, the inspector cannot keep up with the arrival rate. And however, washing center arrival rate is 0.30 that is 1 divided by 1 plus 3 plus 6 divided by 3 that's equal to 0.3 and this arrival rate value is greater than the sorry this service rate value is actually greater than the same arrival rate of 0.267. Actually, the customer moved to the first washing center, then inspection center. So that's why the arrival rate same would remain same, but the service rate of the washing center is more than the arrival rate. So uh, in this case, the process is probably the good one, but this case, the inspector can't bear the queue length. There is a congestion at this station actually. So if I run the simulation again, so you can clearly see the length or queue length at the inspection center is more as compared to the previous workstation 1 and 2. Thank you.